मीटिंग दिया ही अच्छा हुआ। मैंने पासवर्ड दिया है।
First we go through the last class, what we have discussed. Then we go for the next class.
पासवर्ड आया। इसमें वो मीटिंग आईडी का पासवर्ड मारो बोल को नहीं आया।
साइनमैन क्या है? साइनमैन का?
That is the student part for miserable class.
आज ये टाइम
सेल वाले
Okay. Last class we discussed about introduction related to the electrostatics and electromagnetism. So these are the two concepts. So one is the electrostatic field and second one is the electromagnetic field. So both are similar, having the similar characteristics, but the field of electrostatic and electromagnetism will be different. Means the production of electromagnetic energy as well as electrostatic energy can be further divided into two subtopics in case of the magnetism. So first one, electrostatics is nothing but, for example, one electron, whatever it may be negative charge or positive charge, if you keep in a free place or free space, so it will be create a field. It will be create a field. So that is will be we are called as a electrostatic field. Means in a circumstances which is try to attract the opposite poles. So it may be positive charge or it may be negative charge. For example, if you are consider magnetism, if for example we are placing the north pole, so that will be try to attract the south pole within a circumstances. Or we are placing a magnet, they are trying to attract the iron pieces. Whatever the metal pieces is available, so they are trying to so that is will be we are called as a field. So there are two fields is available. One is the electrostatic field, second one is the electromagnetic field. So electrostatic field produces by means of charges passing through a current, or it may be stable or it may be movement. So in case of electromagnetic field, so that is produced by means of the completely electrons only. Electrostatic field can be produced by means of positive charges or negative charges. Both are possible. But in case of electromagnetism, so the initiative taken by means of the electrons only. So whenever electron movement will be take place, it will be produces that we will call as a electric current. So whenever current is passed through that, so each and every one, it may be positive charge or it may be negative charge, it is having a field. So because of movement of electrons, a field will be created. So that is we are called as a electromagnetism. In detail we are discussed in the next in this chapter. So in the introduction we see about, so these theories will be invented by means of Hans Christian in 1819. So he is a Danish physicist, or we are called as a scientist. So he observed whenever the magnetism will be placed, whenever the electrons will be flowing through a conductor, a needle is placed near to that conductor, so then it will be create a force. That is a deflection force will be created. Already we know that the magnetism can be possible to produce the deflection force in case of the metals or as well as the magnetism. So in this case he observed the metal piece, that is we are called as a needle, it is a deflects. So in the both directions, whenever the currents will be reversal. So once he change the positive to negative, another time he change the from negative to positive. So in this both directions, whenever the current is changes, the deflection force also changes. So he is observed, so he is invented the theory, that is we are called as a electromagnetism. Because the production of magnetism by means of the electrons, because of that reason, that will be we are called as a electromagnetism. So there are two types of magnets available in the universe. First one is a electromagnet, second one is a magnet. So magnet, that is will be we are called as a natural magnet and electromagnet. Natural magnet is available or we are discovered by means of the naturally. So in the magnetic mines, whatever is available, so from that we are collecting the magnets, that will be here called as a natural magnet. So it is one type of stone. So there are a few mines are available. Right? There are few mines are available for production of natural magnetism. But one of the major drawback with the natural magnetism, so the size of magnet will be increases whenever the rating of requirement will be increases. That is a major drawback. So for example, we are taking for 1 ampere, the size is up to 10 centimeters. So 10 centimeters of motor or machine, we can easily compact. So maximum 30 meters, 30 centimeters, so we can compactable. But so if the rating is increases to 20 amps, 30 amps, 50 amps, 100 amps, so if the rating is increases, the size of the magnet we are provided in the core is also increases. So then with a 100 amps, it will be occupied a room size. A small room size of the magnet will be required. So it is not possible because the designing is difficult. At the same time, the shaping of the natural magnet is also, it is very difficult. So to overcome that problem, so the electromagnetic theory will be invented. So what we have discovered in electromagnetic theory, so with a small quantity of electrical energy, we have used it to produce the same amount of the current, or we can utilize the current for the given application. So generally, we are using as a machine as a two manners. One is for the generator, which is produce the electrical energy, that is we are called as the generators. The next second one, we are convert electrical energy into mechanical energy, that will be we are called as a motor. So generally, we are see the applications of the motors. Domestic applications also we are used it. So for example, mixers, grinders, blenders, so micro ovens, at the same time water pumps. So these are all is working with the motor principle. So it may be AC or DC is the rest of the matter, but basically they are working with electrical energy. So they are utilizing electrical energy and converting to mechanical energy. So similarly, so how can we produce, how can we get the electrical energy? By means of the generating station. So what is the equipment used in the generating station is nothing but, that is we are called as generators. If it is produced DC, we are called as a generator. If it is producing AC, we are called as a alternator. So there are two types of generators is available. So those things will be we have discussed in the next semester. So it may be come from the third sem or the fifth sem will be we are getting the syllabus related to the motor and the generator. But we know the basic thing, there is a two types of machines are available. So in case of generators or motors, the rating is increases, the size also increases with help of natural magnets. But whenever we are using electromagnet, a small portion of current can be utilized and the size will be reduced. So there is no design complexity because the size is compactable. At the same time, the designing is very easy. So just a small quantity of electrical energy we can utilize it, because the cost of electrical energy also is very as compared to the so these are the all merits with the electromagnet. So most of 95% of applications is made by means of the electromagnets only. So but major difference natural magnets is a permanent magnet. Electromagnets is a temporary magnet. So how long the current will be flowing through that electromagnet, that time only they are acting as a magnet. The rest of time they are not acting as a magnet. But natural magnets, they never lost their magnetism. So those will be we are called as a permanent magnets. Already we know the basic things related to the what is a magnetism. Diamagnets and ferromagnets is available. So which one is we are called as a permanent magnet, which one we are called as a temporary magnet. Those things will be already we have studied in the previous classes. Right? So this is about the introduction. So he is observed, so from these two diagrams, so there are two diagrams is available. When the current direction is upward direction, the field is in the counterclockwise direction. Whenever the current is downward direction, then the field of electromagnetic will be in the clockwise direction. Just we are assuming we are taking a cardboard and we are inserting a pin exactly middle of the cardboard. So if we draw the imaginary line, so this type of circulars can be we are obtained whenever the current is passing through the conductor. So this is about the introduction. So next we discussed about Coulomb's law of magnetism. So Coulomb is discovered two theories. One is the force is exist between the poles is discovered as a attraction force as well as a repulsion force. So whenever the magnet is placed one place, if another magnet will be we are closer to that, so there is a two forces will be existing. For example, if the existing pole is a north, then it will placing the north pole, so then the repulsion force will be existence. Similarly, if you are placing south pole in a free space, if you are keep near the south pole, so it will be repulsion force will be existence. If you are taking the north pole, then it will be produces the attraction force. So that is the basic concept. So attraction force, so the same poles are repulsed to each other, opposite poles are attract to each other. So that is the primary concept. Next, secondly, he discovered about if there are two charges will be placed in a free space, the force is exist between those two also. So that is the invented, that is discovered by means of a simple formula. Means the expression for force can be discovered as the force is directly proportional to the product of magnetic strength, the pole's magnetic strength, and inversely proportional to the distance between those two poles. So here we are taking as a two poles as a 1 and a 2. So just we are assuming the magnetic strength of that poles as a M1 and M2. So just we are assuming two poles as a. So according to his statement, so we can write the formula F is equal to M1 M2. That is the one formula. F is directly proportional to 1 by d square. Is nothing but F is inversely proportional to d square. So from that is equation 1 and that is equation 2. So the equation 1 and equation 2 is both in force. So because of that reason, so we can simplify it into a single formula that implies F is directly proportional to M1 M2 by d square. So always we are removing the proportionality. To remove proportionality, we are substituting a constant that is as a K. F is equal to K into M1 M2 by d square. So that is the formula for force exists between the two poles. So here the K value is a 1 by 4 pi mu naught into mu r. So mu r we are called as a relative permeability and mu naught is the absolute permeability. Permeability, the word itself is permit. So if it is permitted, so that will be we are called permeable. So there are two types of permeabilities available: absolute permeability and relative permeability. Relative permeability for air or vacuum, we are taking as a 1. Right? So today, so instead of that we are substituting directly the K value. So F is equals to M1 M2 by 4 pi mu naught into mu r. So mu r value we are considering as a 1. So that's why we are taking the final equation F is equals to M1 M2 by 4 pi mu naught into d square. Already we know the units for force is a Newton. Force per unit is a Newton. Today we discuss about absolute and relative permeability of a medium. So here we can observe the permeability can be represented by means of the mu. Greater generally mu, that for the permeability. So you can see the definition: the ability of a material to conduct magnetic flux through it is called permeability. The ability of a material to conduct magnetic flux through it, we are called as a permeability. So that is for different materials. For example, so when a current is passing through a conductor which is produces a magnetic field, so that is the basic concept from the beginning we are discussing about that. For example, another conductor we are placed near to that. So whenever the magnetic field is not constant, it is continuously flowing like as a waves. So whenever another conductor will be, we are taking closer to that conductor, so by means of the wave, it will be intersect with the conductor. So which results the same amount of magnetism also produces in the secondary conductor. So that is we are called as a Faraday's law. So we in detail we are discussing about the Faraday's law. So according to his law, what we can say here, so whenever a conductor or a material produces a magnetism, when we are closer to that another metal or it may be conductive material, so which is able to receive the field. So that ability or acceptability we are called as a permeability. So ability. Perm is nothing but permission. Ability available గా ఉంచేదాన్ని మనము permeability గా కన్సిడర్ చేస్తూ ఉంటాం. So that is we are called as a permeability. So the ability of material to conduct magnetic flux through it, so which is able to access or which is able to receive or which is able to allow the magnetic field, so that is will be we are called as a permeability. So there are two things will be already we have discussed. One is permeability and the relative permeability. So here absolute permeability can be defined as it is a ratio of E and the magnetic field strength. First we know the what is meant by density and what is meant by strength. So that thing. So here density is nothing but, for example, the North Pole, just we are assuming it is a South Pole. So always the magnetic field or flux lines will be flowing from North Pole to South Pole. So for example, here how many lines is flowing from here north to south? There are 3 lines is flowing from North Pole to South Pole. So at the same time, so if you are increasing, it is a 4, 5, 6, 7, 8, 9, 10. So they are not overlapped to each other. There is possibility very closer narrow gaps will be present in case of the magnetic line. So this is